Okay, so today we are going to just do an overview of sort of what we've learned so far, which would be vertex form and factored form. And I'm also going to introduce a third form that we can express quadratic functions in. So vertex form is titled accordingly. Vertex form is going to be the equation that shows us where the vertex point is on the parabola. So we know that the vertex is at the point HK when we have our quadratic in this format. We also know we can see like a couple other things as well, like HK tells us about like the shifts that happen, and A will also tell us whether the quadratic opens up or down, and if we have any vertical stretch or compression factor. Okay, I introduced to you guys a week ago factored form, and this equation shows us where the x-intercepts are on the parabola. And these can be found at R0 and S0. And similar to the A value in vertex form, the A value in factored form can also tell us whether the quadratic opens up or down and has a vertical stretch or compression. So these A's are really the same in both formulas. And then the last thing that we're going to look at today is called standard form. So in grade 9, when you learned about lines, we talked about how there's different ways that you can express a line. We can express it in y equals mx plus b form. There's also standard form, which is like ax plus by plus c equals 0. And this is standard form of a line. We also have standard form of a quadratic. And that's essentially just like the expanded version of a quadratic. So we see ax squared plus bx plus c. And the a here is actually the same as the a's that you'll see in across each of these formulas. So the A actually still tells us whether the quadratic opens up or down, and it can also tell us the vertical stretch or compression factor. It also shows us the constant value of the standard form equation, shows us the y-intercept of the quadratic. So the y-intercept can be found at the point 0, C. And that's because whenever I have something crossing over the y-axis, that's where x is equal to 0. So if I entered in 0 for both of these x's to solve for what y is when it crosses the y-axis, I would just be left with c. So the c value will tell us the y-intercept. So we have all of these forms, and similar to our equation of our lines in grade 9, the equations can all tell us different pieces of information about the specific quadratic. So we're going to learn today how to go from these forms here into standard form. And we do this by essentially expanding out and using the distributive property. So you guys learned about the distributive property, for instance, how to expand something like this in grade 9, right? What I would do is I would take the 2 and I would make sure the 2 gets multiplied by both terms in the bracket. So that's distributive property. We're going to use distributive property, except this time it's going to be with what we call binomials. And binomials are bi standing for 2, nomial standing for term, so 2-term expressions. And we're going to see how we can expand those things. So we're going to use something called FOIL. And FOIL is essentially an acronym that like each letter stands for something. So the F in FOIL stands for first, O stands for outside, I stands for inside, and L stands for last. So this will make a little bit more sense once we actually go into example 1 here. So when we do FOIL, basically FOIL is telling us we are going to multiply the first terms in each of the brackets. So the first terms in each of the brackets would be 2x times x, which gives us 2x squared. Okay, so that's firsts. The next one is outsides. So the outside terms are essentially the terms that are on the outsides of the brackets. So I'm going to do 2x times positive 3. And that's going to give us positive 6x. So So that's outsides. And then I for insides means I'm going to multiply the two terms on the insides of the brackets. So I will do 4 times x. That will give us positive 4x. And then lasts. So the last term in the first bracket times the last term in the second bracket. So I'm going to do positive 4 times positive 3, and that will give me positive 12. So essentially what this means is that the 2x needs to be multiplied by both terms in the second bracket, and also the 4 will need to be multiplied by both terms in the second bracket as well. So in the end, we've actually multiplied every single term by one another. Okay, and then we're just going to collect like terms. So I'm noticing here that we have a 6x and a 4x, and we're just going to add those together. So we'll end up with 2x plus 10x plus 12. Okay, so we've now gone from something that's in that bracketed factored form into standard form. So this would be fully expanded and simplified. Lila, go ahead.
Will Ouija be doing backwards foiling?
Like going from this to this?
Yeah.
Yes, we will.
Okay.
Not today, but the next time I see you guys, we will do that.
Okay.
Okay, so we're going to practice a couple more here. So we're going to apply FOIL. So first, 3x times, or sorry, 3a times 2a. 3 times 2 is 6. A times a is a squared. Outsides, so 3a times negative 4, that gives us negative 12a. Insides, positive 4 times 2a gives us positive 8a. And then lasts, so 4 times negative 4, that should give us negative 16. Okay, check along for like terms. So I'm seeing that we have a negative 12a and a positive 8a. That needs to be simplified. So we'll put those together and we should get negative 4a minus 16 here. Okay, if you see something like this, when I say squared, it means that thing times itself. So one really huge mistake that we always see people make, we even see people do this like in grade 12 calculus, I'm not kidding, is they will distribute the squared on both of these. They'll say, don't write this, but they'll say, oh, this must be 2x squared plus 5 squared. That's how I expand this, but that's actually not true. When we say something squared, we mean that thing times itself. So what this actually means is 2x plus 5 times itself again. So it's 2x plus 5 times another 2x plus 5. And in order to expand this, we need to FOIL it out. So we'll do firsts. 2x times 2x is 4x squared. Outsides, 2x and 5. Make sure you're paying attention to the positives and negatives. This one only has positives, but we want to make sure, like when we expanded here, we were making sure that we got the correct positives and negatives as we were expanding. So 2x times 5, that should be positive 10x. And then insides, 5 times 2x should give us positive 10x again. And lasts will give us 5 times 5, which should be positive 25. Okay, gather your like terms. We have a positive 10x and a positive 10x that need to be gathered. So that will be 20x. Okay, feel free to raise your hand at any time if you have questions or you need to see anything again. Okay, so as a bit of an extension for this, we've been going from essentially factored form into standard form. Now, we can also go from vertex form into standard form using this FOIL idea as well, but it's just in a slightly different format. So when I want to convert from vertex form to standard form, I need to essentially expand out the entire thing and then gather all the like terms. So as what we talked about in our previous example, when I see x plus 1 squared, it really means x plus 1 times x plus 1. And this is sort of a new thing for us in this foiling lesson where we have a number that's out front of this set of brackets. So what I'm actually going to do here is I'm just going to put a set of square brackets around this just so that I remember that once I actually FOIL this out, the -2 actually has to go into every single term that I have expanded. So we're going to start with FOILing this out because we need to start with multiplications. So I'm going to do firsts. And for right now, the -2 is just going to sort of hang out outside. Same with the -8. And we'll see what we get from this foiling. So x times x, that gives us x squared. X times +1 should give us positive 1x. We don't usually write 1x though, so I'm just going to write plus x. 1 times x, again, that gives us a positive x. And lasts 1 times 1 gives us a positive 1. Move this forward a little bit. Okay, I'm going to simplify inside the bracket quickly here. So I'm going to have x squared. X plus x is 2x plus 1. And then this -2, actually needs to be multiplied by each term in the bracket. So we're going to have -2x squared, -4x, and -2. And then we still have the subtract 8 on the end. And I'm seeing a couple more like terms here. I have -2 and -8 that can be put together here. So we're going to have -10 in the end. So now we've gone from something in vertex form, and now this is in our y equals ax squared plus bx plus c standard form. Okay, I'm gonna have you guys get a little head start. I want you to see if you can FOIL this out yourself. So see if you can start with x minus 4 squared and get that FOILed out. All right, I am slowly going to start putting my answer up, but keep going if you're already started here. Okay, so this is what you should have got for your solution. Remember, if I'm distributing a half into something, I'm really just taking half of each of the values. So I left half here, but when I distributed half into like -8, for instance, I just took half of 8, which is 4. And then when I distributed half into 16, for instance, I took half of 16, which was 8. So that's how I sort of did that. Really just dividing them by 2. Any questions on this one? Okay. So we are going to take a few minutes here and we're going to go and do some practice on foiling. So I have some questions that I've assigned to you guys. So I'll just share those with you. So the questions are from chapter 5, lesson 1, part 1, the foiling worksheet, 1, 6, 8, 12, 17, 19, 23, 24, 26. If you can do 23, 24, 26, you could probably do any of them. But they do get a little bit more complex as you go along, but the same general process is the same. So I want you guys to take, let's say we will meet back here at about, it's 9:10 right now. So I'm going to give you guys 40 minutes to work on this. We'll meet back here at 9:50, and then we're going to do our second section. So 9:50, you are welcome to come back in here if you have questions as you're working, but I'll see you guys back at 9:50, okay?